Hey, Pre-Calc students, this is Unit 12, Day 4. Today we're taking a look at some more evaluating of limits. And there's going to be a really specific thing that we look at within our limits today of how to evaluate. Because what we'll find in this very first example here, where we have the limit as x approaches 4 of x minus 4 over radical x minus 2, we're going to find some issues right away. And they're issues that we're familiar with. So when I go to start evaluating a limit, the first thing I try is plugging in 4 for x, and we get 4 minus 4 on top. And the bottom is radical 4 minus 2. So that becomes 0 on top. Square root of 4 is 2, so minus 2 would be 0. And we get to this form that's called an indeterminate form. We've seen this come up before in examples where we have, let's say, a polynomial over another polynomial. And factoring has really saved us in those cases. What we'll find in this case, though, is that there's not really a good factoring technique to use to be able to show that, yeah, these two quantities have something that will cancel in common. So when you have radicals in your fraction, the trick to doing something like this is to multiply by the conjugate. And doing that will create an equivalent expression, which will allow us to be able to evaluate this limit. So as a reminder, what is the conjugate? Well, the conjugate is taking the denominator, radical x minus 2, and basically just putting a plus sign in between the radical x and the 2. Okay, so the conjugate of radical x minus 2 is radical x plus 2. Perfect. So here's what I want you to do. On the top, that's the non-conjugate pair. I want you to leave those separated. So in other words, I don't want you to FOIL those together. I don't want you to use any box method. I want you to leave those as is in the numerator. But I do want you to multiply the denominators together. And when you multiply conjugate pairs, if you're somebody who understands what FOIL means, the outside and the inside cancel. If you're a box method person, you'll have two boxes that cancel out, because you'll have a 2 radical x and a negative 2 radical x, which will go away. So basically, if I just do the first terms, radical x times radical x is x. And then the last terms, negative 2 times 2, which is negative 4, hopefully you can see at this stage why I didn't want to multiply these together. And this will always happen in these examples that, hey, those x minus 4s cancel top to bottom. So because of that cancellation, I can now evaluate the limit as x goes to 4 of the quantity radical x plus 2. So if I plug that 4 in, we get the square root of 4 plus 2, which would be 2 plus 2, or 4 is the final answer. Okay. So this multiplying by the conjugate idea, it's really whenever you see a radical quantity, a radical binomial specifically, multiplying by the conjugate will be the trick that will help us to be able to evaluate our limits. So let's try another example where we have the limit as x approaches negative 1 of the square root of 2 plus x minus 1 over x plus 1. The thing is, you do want to check that you're getting 0 over 0 first. You don't want to just start by multiplying by this conjugate idea without seeing if this comes out to be 0 over 0. Well, you can check that in your head. If I plug in negative 1, we get the square root of positive 1, which is 1, minus 1 is 0. Negative 1 plus 1 is 0. So if you notice, either by showing the substitution or checking in your head that this is 0 over 0, we're going to multiply by the conjugate in this example as well. Notice how the radical's in the numerator, and that's okay. The conjugate's going to be radical 2 plus x plus 1, and we're going to multiply the top and bottom by that. Don't change the sign inside the radical. It's just the sign on the outside that separates the radical and the constant there. Okay, so when I go to do that conjugate pair in the numerator, it's the limit as x approaches negative 1 of, remember for the conjugate pair, I'm just doing the firsts and the lasts. So the first would be 2 plus x. The last would be negative 1 times 1, which is negative 1. And if I follow my own rules that I suggested up at the top, the bottom pair, which are not conjugates, leave those separate. Don't try and multiply them together, because it's going to be tougher in the end to recognize things that need to cancel. Okay. Combine like terms on the top. Check it out. We get 2 minus the 1 is an x plus 1. Perfect. And the reason why I say that's perfect is because we have that x plus 1 quantity in the bottom. So once those x plus 1s cancel, I'm going to rewrite what I have left over. Just be cautious that when nothing's left in the numerator, we know that there's a 1 up there. Now that I've done some algebraic simplifying, we should be able to take the limit as x approaches -1. So if I plug in a -1 right down here, we get 2 minus 1, which is 1. So radical 1 plus 1 is the denominator, and the square root of 1 is 1. So that, in the end, turns out to be 1/2. Okay. Hopefully we're kind of getting the idea here. Let's go ahead and try maybe just one more example, and then we'll save the rest for some in-class practice. If I take the limit as x approaches -3 of the square root of 1 minus x minus 2 over x plus 3. Okay. There shouldn't be much of a surprise that I chose another example that's 0 over 0, but did you check it, right? Plug in -3 for x, 1 minus -3 is 4, square root of 4 is 2, minus 2 is 0. -3 plus 3 is 0, so yep, definitely that indeterminate form. Multiply by the conjugate of what's up top here, which is square root of 1 minus x with a plus 2. Do the same thing on the bottom. Okay. When I multiply these together, it turns into the limit as x approaches -3 of, well, conjugates on top. The first would multiply to 1 minus x minus the last, which is 2 times 2, which is 4. Okay, leave the bottom alone. Don't multiply those together. Go ahead and simplify the top. So this would equal 1 minus 4 is going to be a -3. So the top is -x minus 3. And the bottom is x plus 3 times radical 1 minus x plus 2. All right, now at this stage in the game, it's been pretty clear, I think, in the last few examples, what cancels right away. And maybe it's pretty clear to you right now as well, but there's nothing exactly in common yet until I take out a -1 from the numerator. Then these x plus 3s would match. So if I write this as -1 times x plus 3, that might be to my advantage, such that I can see, oh yeah, those x plus 3 factors cancel. And now we have the limit as x goes to -3 of, well, the numerator is -1. The denominator is radical 1 minus x plus 2. So a pretty similar situation to number 2, but notice how we have a -1 left on top as opposed to the +1. Plug in -3, so we get -1 over the square root of, well, 1 minus -3 is 4 plus 2. And because the square root of 4 is 2, 2 plus 2 would make the bottom 4. So the final answer here is that the limit as x approaches -3 is -1/4. So we can do some algebraic manipulation in other instances with 0 over 0, other than having things that we factor. This new idea with the conjugate will certainly come up in practice and will be the main focus of our next homework assignment. Okay, so that's it for today's lesson. It's a quick one. If you have any questions, let me know next time we're in class. Have a great day.